Yeah, good day everyone. So this particular question is one of the many questions you guys were asked in your Physics 101 CA question. So, and it's on equilibrium of forces. I choose to make a video about it because in the past question I solved for you guys, this topic is not like in the questions. So, but before I solve this question, I'm going to be explaining some key concepts that you need to know so that whenever you are like given these questions in the nearest future in assessment or exams, you'll be able to tackle it heads on. So let's get started. There are some keywords you need to note. If they say uniform meter rule, the uniform meter rule has its balance point at the 50 centimeter mark. Let's say this is a meter rule and you place a knife edge. It's going to balance at the 50 centimeter mark. That means that that's where the weight will lies. But this particular meter rule in this question is not a uniform meter rule because the balance point is not what? It's not at 50 centimeter, it's 48 centimeter mark. So let's get started. So generally, when you place like a meter rule on a knife edge, it's going to balance without adding any weight to it. When you add like let's say a mass to this end, the balance point will change. It might like you might have to change the knife edge to this point so it will balance. So, and if you had another weight, you might have to change the balance point again to make it balance freely actually. So that's the whole concept of this topic. So the next, they said a meter rule is found to be balanced at the 40 centimeter mark. Generally, if they said a meter rule, we assume that it is 100 centimeter in length in physics. So let's say this is the meter rule. Now say it's balanced at the 40 centimeter mark. That's where the weight lies. So do we know the weight? We don't know it. That's x gram. That's where the mass lies. When now said when a body of mass 0.1 kilogram is suspended at 6 centimeter mark, I assume that this particular point is the 48 centimeter mark, right? From here to here is 48 centimeter. Automatically, you agree with me that from here to here will now be 52 centimeter. So this is 100 centimeter. This is 0 centimeter. So a mass of 0.1 kilogram. 0.1 kilogram is the same thing as let's say 100 gram. The reason I'm converting to gram is because the options are in gram. So from here to here is what? Is 6 centimeter, right? And I've actually established the fact that here to here is 48, right? So let's continue. The answer, the balance point is found to be at the 30 centimeter mark, which means that like the pivot is not like here anymore. It's now here after they hung this mass on it. It's balanced at what? At the 30 centimeter mark, 0 to 30. Let's say here, the knife edge is not here. Shall you get? So from here to here is 30, which means that from here to here will not both, which will be 24. You agree with me? And since from here to here is 30, automatically from here to here, the whole length of here is 40 centimeters. This one will be 16 centimeters, right? So we now said, what is the mass of the meter rule? Yeah, we have like this is where the whole work actually lies. We now can now apply the clockwise moment and anti-clockwise moment. So here and here, which means that the sum of clockwise moment will be equal to the sum of anti-clockwise moment. 100 times 24. 100 times 24 will be equal to what? 16 times x, right? So, sorry. This one is 18, right? This one should be 18. Because I said from here to here is 30. And the whole thing here is 48. So, from here to here should be 18 centimeter. 18 times x, right? So, which means that my x will be equal to what? 100 times 24 all over 18. So 6 here, 4, right? 6 here, 3, right? So 3 here, 1, 3 here at 3.3. At 3.3 times 4, that should give me 133.3 gram. So the correct answer is what? Is B. So thank you.